Section 4.4 will introduce us to the solubility rules for ionic compounds so we can predict when a precipitate will occur, allowing us to write complete ionic and net ionic equations to describe this process. Unfortunately, this does require rote memorization of solubility rules so we can predict precipitation reactions. Let's begin. In an earlier lesson, we defined soluble ionic compounds as those that readily dissolve in water. For now, we'll consider insoluble compounds as those ionic compounds that do not readily dissolve in water. In Gen Chem 2, you'll learn how to handle these compounds in greater detail because they do dissolve to some degree, but not nearly as much as the soluble compounds that dissolve completely. The solubility rules classify ions and compounds according to their general behavior. First, ammonium and group 1 metal compounds are always soluble. Second, nitrates, chlorates, perchlorates, and acetates are also always soluble. The halides, chloride, bromide, and iodide, are soluble except for when they form compounds with silver, lead-2, and mercury. Fourth, carbonates, sulfites, phosphates, and chromates are insoluble unless they're paired with an element from Rule 1. Fifth, hydroxides and sulfides are insoluble except when paired with ions from Rule 1 or barium. Silver, mercury, and lead-2 salts are insoluble except when paired with the anions from Rule 2. And finally, all sulfates except calcium, barium, strontium, silver, mercury, or lead-2 are soluble. This table nicely summarizes the information just covered in the 7 guidelines. Note that S means soluble, meaning the combination of ions will dissolve, while SS or I refers to slightly soluble or insoluble compounds. For our purposes here, SS and I can be considered insoluble. Finally, some compounds decompose when added to water, such as magnesium sulfide. You won't be held responsible for knowing what decomposes, only which ion combinations lead to soluble or insoluble combinations. Let's practice. Are the following salts soluble in water? Refer to the guidelines until you have them memorized. When you mix 2 soluble ionic compounds together, the ions can switch partners, and you'll either see no change, indicating that a reaction did not occur, or you'll see a cloudy substance form, indicating that a precipitation reaction has occurred. We can determine the identity of the 2 new compounds that could form using what we've learned about writing formulas for compounds, then reviewing the solubility rules to see if an insoluble precipitate will result. Let's work through one together. Suppose we're tasked with mixing sodium chloride with silver nitrate to see what results. Both compounds, sitting in their own beakers, are clear liquids consisting of the hydrated ions. Ions of the opposite charge will attract one another. When this happens, 2 new compounds can form. Ones that are soluble remain in solution as the hydrated ions, while insoluble compounds will precipitate out as a solid, as shown in this image on the left. Here are 2 for you to try. You'll predict the products of each reaction, then determine if the products are soluble or insoluble. If the products are soluble, then you would say that no reaction occurred. If the reaction does produce a solid product, then identify that product. Figure 4.17 provides an opportunity for additional practice in the textbook, as does the end of chapter problems. When writing these reactions between two ionic salts, we've been writing the overall or total chemical equations. The second reaction I wrote in the AGCL example and repeated here was the ionic equation, showing all soluble compounds as the hydrated ions in solution rather than as neutral intact compounds. Note that some ions show up the same on both sides of the equation. If we remove these spectator ions, we're left with only the ions that participate in the formation of the solid, the part that does the reaction. This is called the net ionic equation. Here's one for you to try. Can you eliminate the spectator ions to generate the net ionic equation from the ionic equation given? Here's another one to try. Given this total equation, can you write out the ionic equation? Using the ionic equation, can you write out the net ionic equation? Here are the step-by-step solutions for your review. As always, I'll leave you with the parting thoughts of the authors. Be sure to let the video finish playing through so that your grade transfers to Canvas.